Dr. Dave Stojdl to come forward. So I think a lot of people in the room will probably have heard about your research, but maybe some won't have. So can you just kind of,
sure,
high level, how you spend your day?
I'm a basic researcher, and so what we try to do is understand the underpinnings of how disease works. And in that process, occasionally, you find an opportunity in which you could come up with something that may actually be clinically valuable. Most of the time, that doesn't happen, but very rarely, just by accident, most of the time, you find something where, maybe the stuff you spend your days doing may actually lead to something valuable in the clinic. And so one of these opportunities is the use of viruses, of biologic therapies, to try to attack a problem that has plagued us for, thousands of years, really, and which is cancer. And as we understand more and more about how cancer works, we're realizing the really daunting task that's in front of us. And there's a couple of key things that are important. One is that it's pervasive. So half the people in the room will likely have cancer. And as the statistics go now, a third may in fact die of the disease. So it's not a rare disorder. But people use cancer as a catch-all phrase for actually talking about hundreds of different diseases. And the problem is we've attacked this catch-all with a few simple tools. They've served us incredibly well up until this point, but all of us know situations where they've just not been valued. And so, mostly because of the simple tools that we're building. And what we've worked on for years is to try to make much more complicated therapeutics that match the complexity of the disease. So in the room, unfortunately, there will be people that have maybe lung cancer. But all of those people with lung cancer will not actually have the same reasons for that. There's genetic breaks in your DNA that would give rise to that disease. And they're different between patients. And so using one drug to try to treat them all is very, some like disease, that's really happening in the clinic. So what we've decided to do is match the complexity of the disease to the complexity of the therapeutic. And using a biological therapy that can set the difference at the gene level, the difference between tumor and normal, is just much more amenable to actually tackling this really difficult problem. And the other part that we've come to realize is that we all carry around the single best defense against cancer in our bodies, which is our immune response. And what's happened with people that present in the clinic is that system has been shut down by the tumor. And these biological therapies that we've been working on are able to turn those back. And so really fundamentally now we're trying to figure out the nuts and bolts of how that process works. Right. And so fortunately it's a very long story, but we're now at the part where we're getting to the point where all these ideas we've had in the lab, all these things we've tested in cell lines and mice, are now at the level where we're putting a patient on in the next month. And that's in adults. And that's just sort of the fastest way to get therapeutics to kids. Now is testing in adults first. And then if they're functional there and they're safe, and we can begin to try to look at those in the pediatric setting. So we are now at the point where we will find out whether this decade-long, 14-year-long experiment is going to bear fruit.
And in terms of that experiment, we know that only 3% of research funding for cancer goes to childhood cancer. So what role do donations and support from the Foundation play in your research?
Yeah, no, I mean it's a long, it's a very important question actually, and there's a bunch of answers for it. The first way I'll answer it is my personal experience. When I first came as a scientist, set up my lab here at CHIO, Research Institute. As a young researcher, you've got a choice to make. One is whether you want to be around 5 years from now, have your lab be successful, or whether you're willing to take a risk on some of the ideas that you have in your head that you think are high risk but high reward. And having to rely simply on the federal and provincial funds that are available, most of the time that's a handcuffing experience because you really only have a very short runway in which to launch your career and try to do things that will have a lasting effect. If you've got these ideas you think someday we should get them. Having donations early on in your careers, I was fortunate to get, filled in this gap, gave you the confidence, gave us the confidence to try and take a whack at some of these really long-term loose contact ideas. And we started that right away, and that allowed us to get this runway to get to the point where now we're actually people as opposed to still just knocking around in the lab. So that's the first thing. And the last bit that philanthropic funds have really been crucial for is there's this gap between knocking around in the lab and testing things in the patients. And that nobody's really funding that gap. And that gap is widening now as pharmaceutical companies pull away from doing their own basic research because it's too high risk, and public funds funding more and more conservative projects because the funding rates are getting low. So, this is probably just getting worse. By putting money into that hole, you build a bridge to get over to the point where ideas in the lab actually make it to the people that matter.
Well, good luck with those trials.
Yeah.